I'm going to talk about a topic that I refused to take on for a very, very long time. It was just the case that we at OMICRON with our tool were at the leading edge of the development, providing means to test with these process bus protocols already 10 years ago. And maybe for that reason, we were approached many times from potential users of these digital technologies. Please tell me, why should I do that? And I by myself said, why should I explain that? This should be the task of those vendors who sell the protection relays and the automation equipment and all the other stuff, to tell the users why they should employ that technology, and then we will sail in the tailwind and give them the tools that they need to deal with this. Nevertheless, users didn't let us go with that. We got this question again and again, and all of a sudden, I also became interested in that and said, maybe it's really not as obvious as I always thought. And then I began to collect a little bit of information about this, and what I found out, I want to share with you now. So what will we have here in this presentation? First, I want to coin this term digital substation again with you. There is no agreed definition, but maybe we will come to a definition, or you will hopefully agree with my definition. Then I think only a combined view of many of these aspects make up the full value of the digital substation. We will go through some specific benefits, which are more obvious or less obvious, and then, as always, we will have a conclusion slide. Okay, the digital substation, how do we define that? Here I have a picture, and it's not my own creation. I got it from a brochure from ABB. They have very coarsely lined up how this evolution of substation technologies evolved over time. They have here this conventional architecture where everything is, let's say, parallel wired up to the station level, and then we have some kind of, maybe sometimes proprietary communication to the network level. Then this evolved. They maybe skipped some of evolutions in between, where we had serial protocols in place, like RS-232 for this 870-5 or DNP connections to the IEDs. And they have here at the next level already something that uses 61850, here between the bay level and the station level, mostly for SCADA purposes, but maybe also for interlocking or something like that. They call that the modern substation. And here they have it labeled digital. It's the digital substation we are talking about. And here we have not only what we often call the station bus, we have also communication down to the process level, where we digitize the information about the voltages and currents from the process as soon as possible, send it over a protocol to the bay level, actually threatening or thinning out the bay level by this, and communicating this up to the station level, and maybe once we will also see it going up to the network level by 61850. You see, I've been very careful in referring to the real source, and I'm almost never using my own arguments in this presentation. I looked up what others say about this. Good. The digital substation uses all kinds of communication services that 61850 offers. we have already a lot of stations in place that we could call modern substations, where we utilize GOOS and client server for the SCADA systems. But now here, the digital substation assume and imply that the sampled values are also applied. And furthermore, to really see the full range of benefits that we can get, we also imply that we use non-conventional sensors. You might know there is a way, and I think this will be also implemented quite a lot, to connect conventional current and voltage sensors to merging units and to digitize it and use it on a process bus. That will be good. That will help a lot. But the full range of benefits will come when we also use non-conventional sensors. Here is a picture from the documentation of a pilot project in Scotland, this fitness project. And in these pictures, they have also explained quite nicely what the conventional approach and what the fully digital approach that they coded in this term fitness looks like, what makes it up here. Again, here, the standard digital signaling on a digital process bus. And there is a publicly available documentation about that. And the words you see here are just copied and pasted from that. What kind of benefits they expect from this. So the fitness project itself is the pilot project, but they have this umbrella project that they call RIIO-T2. There are many installations foreseen within that, and you see these impressive numbers of savings that they expect from applying full digital technologies. And you see they have carbon savings and things like that included in their picture of improvements that they want to achieve. And before we go into some special aspects, here is another example of a presentation which lines up a whole range of benefits. And I hope with the materials that you get that these links were preserved so that you just can click on it. All this material is available also for you to look up what is quoted here. And here we have, let's say, already a palette of benefits which can be expected from that. So there are already a couple of places where you can also see this approach. The whole benefit range together will then make up the whole value. Now let's go into one specific benefit, maybe the most obvious, the one that showed up first and was talked about first. It was the saving of copper. Even that was not immediately accepted by everybody. So people were telling, oh, we have already the copper there, or we are used to it, and it's not so expensive. I don't believe that. Just to outline that, I have looked up a couple of pictures, and we literally bury tons of copper in the ground. And even if it does not look as messy as it looks here, yeah, it is still a mess. And Alex has always a story, I think from his first days at NIPA, where he had a great idea, which was simply brutally rejected because you cannot make any changes in a system like that. Yeah? You maybe won't even find the wire. So the whole bunch of cables come into the relay house or the control room of the substation, maybe like this. And even if you try to do it nicely before you put it into the ground, I still have no other word than saying this is a mess. And even if it is nicely and properly done, it's still a lot of work and a lot of copper that is buried. And I heard it from a guy here in Germany, which is recognized as a very civilized country. He told me that they have ordered twice as much copper as they really use because half of it is stolen. Okay, this is how, when it is nicely done. And here we have an example of a presentation, I will come back later on, where somebody who really looked into that made a picture of how he sees the saving from going from cable trenches like this to a couple of optical fibers that he can just put into one tube. So I really think the copper savings argument alone is a pretty strong one, even if you do not think, let's say, on a more abstract level into the total cost of ownership. And there are also several materials in the internet, and I'm referring a lot to YouTube, that specifically look into this. And here is a link to a presentation of Schweitzer Engineering that really has the title with wire reduction. You can find it by this, and here I have just cut out a scene where it is lined out that many benefits could be achieved by using this digital substation technology. Another example from Siemens. They have a little video about their protection devices with process bus interface, and they say there several times that this technology helps them to turn copper into gold. Here he has these two coins in his hand, pointing out the copper that they are replacing by optical fibers, which they call the gold in this context. So also Siemens is emphasizing on the benefits of saving wiring. And how does it Schneider tell to us? It's not only that we save the copper, the physical material that we do not use anymore, it gets much simpler. The earlier we convert this wired information from the process into a protocol, the simpler the whole thing gets. And they even say it's not only simpler, it's more secure when you do it that way. And I have to refer to a conversation that I had more than 10 years ago with a person from the Deutsche Bahn. The Deutsche Bahn runs an own 110 kV transmission network for their 16.7 hertz energy for the train. And they have a lot of substations for that. And of course, they do refurbishment on a regular schedule. And at that time, this person told me how many loose contacts or, let's say, open wire loops that do not transfer information when they should, they detected when they refurbished the substation. It was a decent number, we thought. They were doing a good job in their maintenance, but you find things like that. And then we made the math. You have so many substations per year, this and that, and then we extrapolated, and we said there are probably in your system more than 100 open wire loops. that will not operate when they should. Okay, everybody goes home on Friday. Nobody sleeps bad about that. Yeah? But the first thing I was asked at that time, what if the goose does not arrive in time? Yeah. Then all of a sudden this problem was obvious for everybody, although it's much better with the goose than with the hardwired contacts. Good. What is not so often a topic is work safety. Actually, many of these issues are kept secret. I don't know why. The industry is making secret out of many things that makes it very hard for us to learn from each other and to improve. Work safety is something that people do not like to talk, especially when it comes to the problem that these work safety issues come from the conventional sensors. Because non-conventional sensors have an advantage in this regard. And bottom line, they are a driver for this digital substation, because all of these non-conventional sensors have interfaces which are not interoperable. The only interoperable point is at the output of the merging unit, where we have a standardized protocol where we then again can combine sensors from different vendors with devices from other vendors to communicate with each other. And to outline to you what I mean with these safety issues from the existing sensors, I think it's obvious to many of you that open CTs are a problem. Yeah. You can have the hazard of electrocution, or you can even have arcing on the outside, on the secondary side of the CT. But what we really also have to keep in mind is exploding CTs. I heard this only 3-4 years ago. And if you look here, here was once an isolator. Yeah? And the pieces that went off here are like pieces of a hand grenade. And it depends on the environmental conditions and on the model and make of such isolators and CTs. It is really, really very, very dangerous. And in some places, this is the reason to go away from conventional sensors. And 2 years ago, I was at the Transformer conference in Australia, and I touched the topic a little bit and asked the people if they know about exploding CTs. And one person who is really in this transformer topic for a long time, she was absolutely not surprised about me asking that. And she said, if CTs explode, yes, that's what they do. And here is another link to an article who specifically goes into this topic. And there are not only exploding CTs, there are also exploding VTs. It's all connected to different conditions, to specific models. You can trace down the problem to a cause that could be removed, but nevertheless, the problem is there. And you better get away from it. Then something that I really noticed when I was looking up all these arguments from the different vendors are the environmental aspects. And when you are planning a substation from the point of view of a protection automation engineer, you want to have this system to work as good, as reliable as before. And things like that are maybe not immediately in the focus of the substation protection and automation engineers. But this is coming into the game on a different level. And you have maybe noticed it on the slide from the fitness project from Scottish Power. They have it there because it's also a total cost of ownership factor for them. What is also obvious, when you do not have oil in your CT, it cannot spill oil out. Yeah? So you can, with these things like non-conventional sensors, also minimize the impact when something goes wrong. What is also recognized in between, that you just need less space. You have a smaller footprint, you need less cabinets, and also Scottish Power brought it down to the point, when you have less stuff, you have to carry less stuff around, and even your transportation efforts are minimized in this course of development. And here are some examples which specifically mention this. Here in the bullet points, they have the environmental aspects here. It is mentioned that the sensors are oil-free, that they only have a fraction of the weight of the conventional equipment. And this is another, let's say, documentation of a project that was conducted in Denmark. So our colleague Peter Diemer, that we know almost 10 years now, because he was really going into this 61850 topic very early, presented his project there. And there was also a statement from somebody from Alstom outlining that environmental and safety issues have been resolved in the course of this project. But there are even more things which come only later on when you look carefully on that. Testing can become much easier. When you do it in the right way, you're much faster in setting up and commissioning the installations on site. And something that I heard only recently, it also has a significant effect on the documentation. And that, at that point, I want to quote the presentation which was given about a month ago at the DPSP in Belfast. Kevin Hinckley from Transgrid in Australia was presenting his experiences, or his utilities experiences, with their Avon Substation project. He gave us a really nice paper, and we awarded him the Best Paper Award at that conference. And he really did his homework. We were there. I've seen his lab, where he really put equipment from 3 vendors on the table, and for many months they evaluated all the aspects that they found are interesting for them in going for such a digital substation project. So they avoided to have all the surprises on site. They sorted it out in the lab, and then they chose which vendors they were using for implementing this. And also other problems were solved before they were going out. And they decided for this version here, you have to read the paper to really understand, but here they have some saving numbers deduced, how they call it, in the desktop comparison results. And he said during his presentation, they expected about 10% cost reduction. What they really got was about 30%. And he talks about this faster commissioning of the substation. When you have less conventional wiring, you have fewer conventional wiring loops to test and all that stuff. It just goes much quicker, especially if you do some smart ways of pre-testing before you bring the equipment out. What you can do now. Yeah? And on the other side, he talked about the system drawings. And he said, we only need 10% of the documentation now. It's just better to handle. That was really a surprising conclusion from him. Yeah, now to our conclusions. There are multiple benefits to be harvested, something which is maybe not directly in the scope of the people who have the protection and automation system running. And there are even some more benefits lying ahead of us, which are maybe also not as obvious. Alex told about other aspects of communication that allow different protection system. And I think there is more to come. As soon as we have this information digitized, are able to exchange these data about the process quantities with the communication, then we will find new ways, we will find better protection systems which really rely on the communication and not on a very, very sophisticated protection algorithm that we might need not as much in the future just because we have information from different points in the system. Now, how can you make use of these benefits? How can you turn that into value for yourself? It's not going by saying to some vendor, give me a 61 or 61850 system. Actually, we have seen such kind of specification where it was a single line saying communication as per 61850. That was the specification. It will not work like this. I think, and maybe that's one of the reasons why you are here, you need to make yourself competent. And vendors will love it when they can talk to you on a competent level and when they do not need to guess what you maybe want to have for your systems. Then you can define what you want to achieve with your system, and then you can make a good specification. And then you will more likely get what you really want and what you need. And then you see there is so much material available outside. Look for best practice. There are pilot projects around. There is documentation about pilot projects around. You really don't need to make any experience by yourself. Yeah? You do not need to repeat any fault that has been made before. And then, important, evaluate your options. Maybe take some of the stuff on the desk, ask for samples, look into this, make yourself familiar with it. And if you still think it's too much, get some advice. If you ask the right people, they can tell you a lot about things that they have heard about, that they have seen somewhere in the world, to tell you more about the best practice which is already around in this world.